even with all the modern technology we have today, the hard truth is, we've barely scratched the surface of what the universe truly is. There's something out there, and even right here, that defies everything we think we know. Dark matter, energy that accelerates the cosmos, holes that swallow even light, and no one can explain them. If you thought the mystery ended with the Big Bang, brace yourself, because what you're about to see might just turn your understanding upside down. Dark matter is like that old family rumor. Everyone knows it exists, but no one can quite prove what it is. Astronomers have noticed galaxies behaving oddly, as if being pulled by something invisible. This something is the so-called dark matter, which makes up about 27% of the universe. Yet, despite knowing it's there, thanks to the gravitational effects it causes, no one has ever seen or touched it. It's like trying to describe a ghost that only reveals itself by moving furniture around the house. Science has tried everything to identify what this matter is made of. They've searched for exotic particles, WIMPs, axions, even strange gravitational effects, but nothing, nada. Even the largest particle accelerators like the LHC haven't provided a concrete clue. And the most intriguing part, it doesn't interact with light, doesn't emit radiation, nor reflect it. In other words, it's invisible to our eyes and the most modern instruments. This makes dark matter one of the biggest headaches in modern physics. Just imagine, the majority of the universe is made of something we don't even understand. It's like trying to assemble a giant puzzle with half the pieces invisible. And the question that lingers is, how can humanity feel so technologically advanced if we still don't know what the universe is made of? Perhaps the answer lies around the next corner of science. Or maybe it's hidden where we least expect. Dark energy is another mystery that makes scientists scratch their heads. While dark matter holds galaxies together, dark energy does the opposite. It pushes everything away. It's as if the universe is caught in an elastic band that, instead of pulling, pushes. Since the 1990s, we've known that the universe isn't just expanding, but it's doing so at an increasing rate, as if it had too much coffee. And who's behind this? Dark energy. But what exactly is this dark energy? The truth is, no one knows. It could be a property of space, a new form of energy, or something we haven't even imagined yet. This creates a huge discomfort because 68% of the universe is made of it. In other words, almost everything that exists is beyond our understanding. So, how can we fully trust our theories if they ignore the majority of the universe? This invisible push challenges our laws of physics and even questions the ultimate fate of the cosmos. Will the universe expand forever until everything becomes cold and empty? Or is there something more hidden in the cosmic margins? Each new discovery seems to raise even more questions. And it's precisely here that we encounter the next abyss of mystery. Black holes are like cosmic safes. Everything goes in, nothing comes out, not even light. For a long time, they were just mathematical predictions. Today, we know they truly exist. But what happens inside them remains a great enigma. Traditional physics simply collapses within them. Gravity becomes so intense that it defies logic. The point of no return, known as the event horizon, is the boundary of the black hole. Cross it, it's over. But what happens after that? No one knows for sure. Some theories speak of a singularity, a point of infinite density. Others suggest that reality as we know it simply ceases to exist inside, and some even speculate that black holes are portals to other universes. What if they really are doors to another reality, or cosmic time machines? It's not just science fiction. These are hypotheses that some respected physicists have proposed. The truth is, to this day, we have no way to explore the interior of a black hole. But they remain there, devouring stars and challenging our understanding. And perhaps what's behind them is closely linked to an even greater mystery. The idea of a multiverse sounds like a superhero movie plot, but it's being taken seriously by part of the scientific community. It suggests that our universe might be just one among infinite others. Universes with different physical laws, different types of matter, perhaps even different yous. The theory isn't new, but it gained strength with advances in cosmology and quantum mechanics. But how do you prove something so beyond our reality? The big difficulty is precisely that. We have no direct access to other universes, if they exist at all. It's like being inside a bubble and trying to see what's outside using only reflections on the wall. Some physicists try to find clues in the patterns of cosmic background radiation, or in collisions between universes that might have left scars in ours. The multiverse raises profound questions about our existence. Are we truly unique? What if everything you know is just one possibility among trillions? Despite the lack of proof, the idea continues to fascinate, precisely because it opens a gigantic door to the unknown. And when it comes to the universe, the unknown is almost the rule. The Big Bang Theory is widely accepted as the starting point of the universe, but it doesn't explain everything. In fact, it begins to explain the universe only after it already existed. What was there before? Why did the Big Bang happen? These questions are still shrouded in mystery and speculation. Some scientists suggest that time and space were born along with the Big Bang. Others consider cyclic universes that are born and die in an infinite sequence. There are also theories that speak of quantum fluctuations in the vacuum, capable of generating entire universes. But none of these ideas have been confirmed, and perhaps they never can be. Thinking about the origin of the universe is like trying to remember your own birth. There's no memory, only conjecture. But the search for this answer is one of the deepest in science. And who knows, understanding how it all began might be the crucial step to overcoming one of the greatest limitations we face today. Science has already taken us to the moon, decoded DNA, and given us access to information in seconds. But there are still limits. Many ideas are beyond our capacity to test or observe. Whether due to lack of technology or understanding, there are frontiers we can't cross. Yet. It's like we're peeking at the universe through a crack in a locked door. A classic example, trying to unify general relativity with quantum mechanics. They're two brilliant theories, but they don't talk to each other. Another limit lies in the instruments we use. Detecting dark matter, exploring black holes, observing other universes, all this requires technology that doesn't even exist yet. It's like wanting to take a selfie of an atom with a camera from 1900. But limitations are also fuel for scientific creativity. Many advances were born from ideas that seemed impossible. The problem is that sometimes progress depends not only on ingenuity, but on a true revolution in how we understand the cosmos. And that's where we encounter one of the biggest current barriers. Relativity and quantum mechanics are like two geniuses who refuse to talk. Einstein explained the macro, planets, galaxies, the fabric of space-time. Quantum physicists handle the micro, atoms, subatomic particles. Both work incredibly well in their domains, but when they meet, they simply don't match. This impasse has stalled physics for decades. Various attempts at unification have emerged, like string theory or loop quantum gravity, but none have achieved experimental confirmation. The difficulty is so great that many scientists already admit perhaps something very basic is missing, an essential piece we haven't discovered yet. As long as we don't unify these two pillars of modern physics, we can't advance toward a theory of everything, one that explains the universe as a whole, without dividing between macro and micro. And this leads us to reflect on the true engine behind this relentless quest for answers. Curiosity is what drives science. It led Newton to ponder the falling apple, Darwin to observe the finches of the Galapagos, and Einstein to imagine riding a beam of light. Without curiosity, there's no question. And without a question, there's no answer. It's what pushes us toward the unknown, even without knowing if we'll find anything there. Scientific curiosity doesn't need a guarantee of success. Often, it's guided by intuitions, even dreams. Who would have thought that playing with magnets and wires would lead to the electricity we use today, or that studying fungi would give rise to antibiotics? Great discoveries are born from small restlessness. And perhaps, in the end, the answer to the greatest mysteries of the universe isn't just in numbers or equations, but in that spark that shines in the eyes of those who dare to ask, "What if?" Because as long as curiosity exists, the journey continues, and each mystery is just a new trail waiting to be explored. After diving into these gigantic mysteries, the question that remains is, what will you do with this knowledge now? Will you continue accepting ready-made answers, or will you start questioning what no one dares to ask? Curiosity is the engine of evolution, and perhaps the next great discovery begins with a doubt that was born in you. So tell me, which of these enigmas stirred your mind the most? Write it here in the comments, share it with those who need to open their minds, subscribe to the channel, and activate notifications. Because here, the universe never stops, and the next video might be even more surprising.